Okay, so what we are doing, this is another thing getting us prepared to be able to solve equations that involve exponential exponents, okay? Exponential variables, exponents that contain the variable, okay? We're going to have to, at some point, juggle some of our equations around a little to make them in a format that is solvable. And this is one of the steps that may need to be done. So we'll spend a couple days on this. But I want you to see I think this is a perfect time, perfect example to see the workings of algebra, how like we get rules, how we get statements in algebra. So one statement that I'm going to tell you here is this property right here. That if I have, so let's say that I have like log base b of m times n, that is identical to log base m plus log base b of n. So what that means, just kind of look at it this way. So m and n, what am I doing with those two letters? Multiplying, okay? Now, they're variables. So let's just say that they are any product that we want to come up with. So let's just say 50, okay? So I'm going to take, and I don't care the base, so let's just say base 2 of 50, okay? Is that number right there, okay? What we are saying is that should be identical, okay? What two numbers can I multiply together to get 50? 25 and 2. So this is saying I should be able to get the same number if I go put 25 there and put 2 there. Does that still give me the same number? Does that make sense? So here we're seeing that the log of 50, the log of a product, is equal to the sum of the individual logs of that factor of that product. Okay. Now, what are two numbers that multiply together to give me 25? 5 and 5, right? So I can rewrite that as log base 2 of 5 plus log base 2 of 5 plus then log base 2 of 2. Does that still give me the same number there? Okay. So that's a property that is true, and that's what this is listed out right here. Okay. But I want to show you why that's true. Because I think that this is something that we're capable of. We have this skill, and it's just a snapshot of all the things that we go through in a math class, all the things we go through in a science class or a rock class. And they give us formulas. You talk about formulas in rock class? Okay, no? You guys don't do like half-life or anything like that? You guys like talk about elements and stuff? And like, do you talk about half-life or anything like that? So you have it in chemistry, but we talk about half-life. Yeah. Good. Okay. But you get formulas. They just provide you formulas. Okay. And I want us to understand that the algebra is why those formulas exist, okay, and kind of see where they're called. It's called the derivation or the deriving of a formula. So I want to display this for you, okay, and I think it's something we can all do. So this is what we're going to do. So the reason the properties that you will be using work the way they do is for the following reason, okay. So first thing we're going to do is we're going to let x equal log base b of m, and let y equal log base b of n, okay? And now it says change both into exponential form. So remembering from section 7.3, we had this rule that said if you have a logarithm, so log of some base of x is equal to y, if and only if we took b to the y, and it was equal to x, right? We went from b to the y, and it came back and gave me x. That's the rule or the definition for a logarithm, okay? Now, in order to maybe see this the best way, what I'm going to do is I'm going to take this one right here, and I'm going to flip it. Okay, so I'm going to write it as log base b of m equals x. Is that okay? Okay. So now if I want to put that blue one in exponential form, I got to follow the same pattern that was listed here in the red. We went from the base, so the base in the blue one is b. Okay. We raised it to that, so the pattern up here was b to the y, but now it's b to the x. Does that make sense? And that came back in the red one to give me, so the pattern was that to there, comes back and gives you that. So now I'm going to come back and give myself m. Does that make sense? So if I take that x equals log base b of m, and I put that in exponential form, I get b to the x equals m. Is that okay? Confused? It says let x equal log base b of m. That's what we start with. That was given to us. M's a variable. It could be a number, any number we want it to be. So we do a 6, 7, 12, 50, whatever. Okay, but we use m because if I say m is a specific value, then this proof is only for that specific value. I want it to be a proof for all values, so we use a letter for that. All right. All right. So now, Now we're going to do the same thing. We're going to do the exact same thing, but we're going to do it with this one. Okay. So again, I'm going to rewrite that as log base b of n is equal to y. And then follow the pattern that was done in the red one. We went from the base b, so write that down. We rose it to the y, and it came back and gave us the n, right? So if I start with log base b of m equals x and log base b of n equals y, then from what we've learned in the last couple of days, the exponential format of that is b to the x equals m and b to the y equals n. Okay? Now, it says find what m times n looks like. Well, m is this thing, right? N would be that thing, correct? So if I multiply those, multiplying m and n together, is that the same thing as multiplying bx times by? Does that make sense? If m is the same as bx and n is the same as by, then when we have m times n, it's the same thing as bx times by. Okay. Now we can augment that a little bit. We can change it a little bit. Okay. When I multiply two bases that are the same base, so maybe we have like 2 to the third times 2 to the fourth. How would you rewrite that as one thing? 2 to the seventh. You add them, right? So we'd write 7, but we could also do this, right? We write it as 3 plus 4. And the reason, so we add the exponents when they're like bases. Well, then right here, I want to rewrite this as b to the x plus y. I can't write it as one thing. I can't write it as like 7 because I don't know what x is and I don't know what y is. So I can't actually do the addition, but I can write the implied addition, b to the x plus y. Is that all right with everybody? Okay. So now what we have, okay, is that mn is equal to b to the x plus y. Everybody all right with that? Mn equals, should have written right here, b to the x plus y. And step 3 says use the definition of a logarithm again. And what it means in this case is to go the other direction. We said that if we had b to the y equals x, that putting that in logarithmic form, that is log base b of x is equal to y. Remember that? That's what we started with. It was this thing right here. I just changed the order, right? Starting out at the exponential side, and get yourself the logarithmic side. So let's apply that to what we have with mn. Okay? I'm going to rewrite this as, just so it's easier to make a comparison, I'm going to rewrite this as b to the x plus y equals mn. Okay, so there's the exponential side, there's the equal sign, and then we got x and mn. Those parts relate, right? They correspond. So let's take that information then and rewrite it over here as a logarithm. Okay, so I'm going to write the word log. Okay, this base becomes the base here. Okay, and then mn. Okay, so here we went, this is the base, come across to here, that then is the argument, and then that should equal your exponent, which is x plus y. Log base b of mn equals x plus y. That's just putting those components in the correct spots. Basically, my thought of it is it's kind of a matching game. Okay, where does b go? What does b relate to down here? So this b and that b, they relate. Where does this b go over here? That's right there. So this b is going to go right there. Okay. The y here goes on the other side of the equal sign up here. So what's the y relate to up here? The x plus y. So that goes on, the x plus y goes on the other side of the equal sign. The x, what's that relate? Where does it go? It goes right here in the logarithm. And that x relates to mn, so mn should go right here on the logarithm. Okay, so now we've got this new statement that says use the definition of logarithm, and we now figured out that that must be true. Okay, and now this last part says, well, once that's true, log base b of mn is equal to x plus y. It now says substitute back in what x and y were. If you remember at the beginning, we said x was log base b of m. So I'm going to say log b of mn. This thing right there is now log base b of m. And then we add to it y, which y, if we scroll back up, was log base b of n. And we see there that that is the separation of that product in that left-hand side logarithm, and it produces the sum of those two logarithms. Huh? We just went through some stuff that we did on Thursday. Yes. Yes. Yep. So my thought is when showing something like this, I'm not going to ask you. Okay, I'm not going to ask you to replicate that. Okay, to reproduce that. Okay. When you hear people talk about taking like college math courses, okay, now it's not going to be maybe the first or second math course that you would take in college, but after you get beyond that, that's the kind of algebra you do. Okay, you move away from algebra, like our practice problems that we do where they have specific values. You move away from that kind of stuff, and you move away from just kind of the repetitive, 10, 15 problems of the same thing over and over and over and over again. And you start dealing with this kind of stuff, and you start doing the real algebra that is the reason that our math works the way it does. Okay. If you understood that, awesome. Okay. If you didn't understand that, you still should not get hung up on the things that we're going to do here in a little bit. But what I want to make sure we understand is that I'm not just giving you a bunch of baloney and saying it works, just take my word for it. There's a reason for everything that we do in a math and science class. Okay, there's always factual substance to those equations, those formulas that they give you. Okay, question. I don't know. But I don't know that I ever. Oh, I get it. I get it. I don't know that I was ever, and I still don't think this. I don't know that I know more math than anybody else, or that I'm better at it than anybody else. I just might work harder at it than other people. Does that make sense? I have it's like I have an issue with not knowing things. So like a lot of times, like Noah comes in and asks me a question about rocks, and I don't know it. Like when you guys leave, like I research crap out of it. It's been ingrained in me through growing up that it's not okay to not know. Okay, so and I just take that into every aspect of what I do. So I've always a lot of this stuff. This stuff blew my mind when I was in school. I hated logarithm. I had Mrs. Coles. You guys remember Miss Coles? I had her with this stuff, and like I sat in your seats and I told her, I don't get this. This is stupid. But it bugged me. Okay, and I needed to understand it, and I knew that it was going to make or break my grade. Like if I didn't do well on it, it was going to hurt me when I hurt my grade, and then when I got home, no, my parents might hurt me because they didn't like my grade. Does that make sense? So like I had that just desire not to be uncomfortable, so I would always take the extra time to dig into something and research it and figure it out, and it mathematically paid off for me. I get it. I get it. Okay. But and especially as like so, when I'm teaching and somebody asks me, like just think about this in your own situation. If you're like really really good at something, or supposed to be really really good at something, okay, and somebody asks you a question and you can't answer it, does that person now look different upon you? And your skill level and your knowledge within that area. So as a teacher, like I don't need to know this to be and you don't necessarily need to know this to be able to do the work that we're about to do. But when somebody looks at me and says, "Why? Okay, why are we doing? Why does that work?" and I can't answer that then sheds a different light from their perspective on me, right? And I don't like that. Yes. Yes. So. Yeah. I should be. Funner? Google funner. Goodness. All right, so that property where we have a product of two numbers in our logarithm, and how we can separate it into addition of those two numbers. And obviously this is called a product, and then this is the sum of their factors. Okay, this is called a quotient, and this is the difference of those, obviously the divisor and the dividend. Okay, so when we multiply, it converts over into addition. Okay, when we divide, it converts over into subtraction. Okay. No, yeah, that's all right. But remember, so addition doesn't matter the order, right? 2 plus 3, same thing as 3 plus 2. And that's because multiplication doesn't matter. 2 times 3, same thing as 3 times 2. So these are commutative. Okay. Subtraction is not commutative, and neither is division. 2 divided by 3 is different than 3 divided by 2, right? Therefore, 2 minus 3 is different than 3 minus 2. Okay? So we need to make sure that this goes numerator minus denominator. Okay? This one here is an example where if you've got on your logarithm, say this is like log base b of 5 squared. Okay? That exponent right there actually comes out in front of your logarithm. So log base b of 5 squared would be rewritten, take that 2 out in front, so 2 log base b of 5. So those two things would be the same. Okay? Just want to demonstrate some of that algebraically for you real quick. And I'm just going to use, it's just easier to write this or type this. If I write log right like that and go, we did 2 times, I'll just do 2 times 3. Okay? What is the base that is being used here? Does anybody remember? There should be a base. Oh, zoomed in too far. There should be a base right here that we're not writing. What is our counting system based on? What is our number system based on? Powers of 10. So this is a 10 here. Okay. So this is log base 10 when it's not written. Okay. But what we're seeing there is that if I've taken those two things and multiplied them together, that's the same as adding those two things, right? Okay. Now, if I were to divide those two things, so let's go 2 divided by 3. Is that then the same thing as their difference? Does that make sense? Okay. Now, understand this is where I said that order matters. I cannot just go 3 minus 2 because it's going to mess the sign up. Okay. So 2 minus 3. In the last one that I was demonstrating there, if I go log of like 5 squared, okay, we can rewrite that as 2 times log of 5. We just bring that 2 out in front. And what's going to happen is that's going to make, if we're able to work with these and do this, it's going to make our solving of equations with exponentials in them a little bit easier to do. Okay. So what we're going to do is practice these things. Okay. First thing we're going to do is, because we can go 2 directions, we can actually go from the separated side. So in my formulas up here, we can go from this side to that side, or we're going to start with this side and rewrite it as that one. Okay. In solving equations, usually we're going to start on this side and try to get it into this format here. Okay, so that's what we're going to start with first. Okay. So when we see, now the key thing here that we need to pay attention to is that this can only be done if the bases are the same. Okay, so if I have log base 4 of 32 minus log base 4 of 2, this is going to work. We can do it. But if I had log base 5 of 32 and log base 10 of 2, because the bases were different, you can't do anything. Okay. So when we look at this one here, okay, what do I do since the bases are the same? So it's going to be rewritten as one logarithm with a base of 4. But what do I do with these two numbers now because of that sign? What did the rule up here say? If you have division, or sorry, if you have subtraction, you turn it into division, right? Okay, so we've got subtraction. Got 32 minus 2. So I'm going to turn that into division. 32 over 2, right? Now it says evaluate if we can. I think we can. If these are all numerical, we can evaluate this. What's 32 divided by 2 the same as? What's 32 cut in half? 16. Okay. Now, if we have a log base 4 of 16, remember that is equal to some number. One number. What number can I take 4 and raise it to get back and get 16? Careful. It's 4 times 4. But what would you raise 4 to get that same thing? What's 4 times 4 using exponents? 2, right? So it would be 4 squared. So this log base 4 of 16 is the same thing as 2. Which means that this thing here is another way of giving you the number 2. Okay? And if we go into Desmos, and this is what I like to check myself with Desmos. Most of your other calculators aren't going to have this ability. if we go function log. So if I go 4, this was 32, minus then log base 4 of 2, do we end up with the 2 that we came up with? Okay. Take a minute and see if you guys come up with this one. It's the same exact style, same exact procedure. So it's going to be, we're going to rewrite this as log base 2 of what? 9 over 3. And 9 over 3 changes to what? 3. So we got log base 2 of 3, right? Now, when we evaluate this, we're asking a question, 2 raised to what power will give us 3? And that's probably not something you know off the top of your head, right? 2 to the first gives me 2. 2 squared gives me 4. So this number should be between 1 and 2. Okay? And in this case, this is where we'd have to grab our calculator. If we wanted the exact value of this, we would have to grab a calculator and say, okay, if I got log base 2 of 3, so 1.58, okay? So if you take 2 and raise it to the 1.58, 4, 9, 6, 2, 5, 0, 0, 7, 2, it does give you 3. All right, so this one. Just merge, don't evaluate it, just merge them. So what are we doing now? What's the sign here in between these two? Addition turns into multiplication. It's going to be log base 10. What are the two things I multiply? 7 times 2. So I merge them. So those two things should be the same. Now again, we'd be asking a question, what do I multiply, or what do I raise, bless you, what do I raise 10 to? What do I raise 10 to so it gives me 14? Well, think about it. 10 to the first is 10, right? What's 10 squared? 100. So my hope is that you can see that 10, so I'll write this down, 10 to the first is equal to 10. 10 squared is equal to 100. Which one of these numbers, 10 or 100, is 14 closer to? 14 is closer to 10. So when we evaluate this, my answer for my exponent better be much closer to 1 than it is to 2. So if we evaluate this real quick, log base 10. Oh. Now, that's the common log, so I don't really need to write that in there if I don't want to. I just hit the word log and it'll do it. And then 14. Is that number a lot closer to 1 than it is to 2? Yeah. Okay. What's next? What is it? What's going to happen here? What's the... Okay, so I've got subtraction, so it's going to turn into division. So this is so it's going to be log. It's always the same. When you have multiple logs, you're always going to write it as one log, right? With that same base. So then I'm going to go 4 over 16, right? Now what does that reduce to? 1/4. Okay. Now this one's a little bit trickier. Okay. Can we rewrite this? Let's just. I would not make you do this, but let's think about the things that this is all of how algebra intertwines and interrelates. Can you write 1/4 using exponents in a different way? Can I say that 1/4 is the same as 4 to the negative 1? You guys remember that? If I've got 1 over 4, that's to the first power right now, right? If I want to get rid of it as a fraction, can I take it to the numerator and make the exponent negative? I can. Well, that's exponential work that we did probably 4 or 5 weeks ago. But think about it. If I go 1 divided by 4, can I go 4 to the negative 1? It gives me the same thing, right? So it's an alternative way of writing. Now, and this is, I'm not making us do this, but let's think about this. Can I rewrite 4 so that it has the same base of 2? How can I rewrite 4 so it has a base of 2? You're on the... So if I take 4, can I rewrite 4 as 2 squared? Is that still 4? Okay. Now, I would still need that raised to negative 1. Okay. Now, what's 2? If I take 2 squared and raise it, anybody remember what we do with an exponent raised to an exponent? Nope. Like if I multiply them. Okay. So if I multiply those, this turns into log base 2 of 2 to the negative 2, right? That makes sense? Okay. So now here's my question. To evaluate this, what do I take 2 to, okay, which is that base? What do I raise it to so that it gives me back this? What does this thing in the box have to be so that it equates to this thing? They're allowed to be negative. We just don't like them to be negative. When we present an answer, we never want them to be negative. But they're allowed to be, and we can work with them when they're negative. And a lot of times, like this, it's convenient for them to be negative. Sorry. But if I'm trying to make this left-hand side look exactly the same as the right-hand side, what does the box have to be? That's a 2, right? Doesn't this have to be that there, right? Okay. So I'm asking, because this 2 right here is this base raised to what number? Will come back and give me 2 to the negative 2. So it's negative 2 is the answer to that. So what I'm trying to get at here is that all this work is what the calculator is doing when we ask it to go log base 2 of 4, log base 2 of 16, and we subtract those, and we get our negative 2 back. Okay. Again, I'm not going to ask you to do that, but that's the algebra. And now my hope is that you can start to see the purpose of us working through things like laws of exponents and that sort of thing, because they are so pivotal in working with logarithms. They are pivotal in working with radicals. They are one of the main, if I were to go through and think about one of the, just list like the top 3 things that we need to learn or need to be comfortable with in algebra when we leave high school. Or, I mean, not even when we leave high school, but when we're navigating the courses in high school, I would think the number, I don't know where I'd put it. It'd be the top 3. Things that we need to know and be proficient at would be the laws of exponents, because they impact so many other branches of mathematics and other areas of the curriculum that if we don't understand them, we're gonna struggle with other things. Okay, let's go a little bit. Let's extend ourselves a little bit. Here's a longer one. Now we're doing multiple things, right? Okay. Now, when you do order of operations, when you do PEMDAS, parentheses, exponents, multiply, divide, add, subtract. Okay. When you get to the multiply, divide stuff, add, subtract stuff, you do that left to right, do you not? So when I add and subtract, I need to do it left to right as I see them, correct? So what this is saying here is that you need to go through this and you are going to navigate left to right as you see them, okay? Now, I overlooked something here before I start talking about that. The thing that we do in PEMDAS first, though, is exponents, correct? if there's ever a number out in front, which we got a number right there out in front, correct? Okay, and that is this scenario right here. If you've got a number out front, then you can make that an exponent in the back. And that's what we're going to do. Okay? So we need to do that first. We need to go through and look at all coefficients. And if there are any, you need to make them exponents. So I'm going to rewrite this as log base 10 of 8 minus, now this is the one I'm going to address. I'm going to put that 2 as an exponent for that 6. So log base 10 of 6 squared plus then log base 10 of 3. All right. Don't worry about making that 6 squared 36 or anything like that right now. Let's just go ahead and keep working with this. Now that I've moved all my, and if there were multiple coefficients, I wouldn't make them all into exponents for their particular log that they're attached to. Now you're going to go left to right as you see them. Okay? So left to right basically means, okay, do that problem right there. These come as a pair, and you do them left to right as you see them. So now, if this is subtraction, what does subtraction turn into for logarithms? Division, good. So we got log base 10. This is going to be 8. If you want to change it, go ahead. If you want to change it to 36, you can. But 8 over 36. Okay? Now, you'd have log base 10 of 3, because that's this part here. I'm just bringing that down. Okay? So now, it turns into, if you've got addition turns into what? Multiplication. Okay? So when I multiply these, so I'm going to multiply those two numbers right there. So it's going to be log base 10, multiply 8 and 3. What's 8 times 3? 24. So we get 24 over 36. What's 24 over 36 reduced to? What do they both divide by? And then 6. So, well, it's not 4 and then 6. It's 4 and then 3. So there's a common factor of 12 in there, right? So is that reduced to 2/3? Okay. So I'm just going to leave it right. So that right there, log base 10 of 2/3, is exactly the same thing. What we're arguing here is that is the exact same thing as log base 10 of 8 minus 2, log base 10 of 6 plus log base 10 of 3. Would you rather, in an equation, if they have that first problem that we start with written out, would it be nicer for us to be able to condense that down to log base 10 of 2/3? And now, so when you're doing these, okay, if you've ever got questions, okay, of whether you've done things correctly, okay, you can always type in what you started with. So log base 10 of 8 minus 2 log base 10 of 6 plus log base 10 of 3 gives me that number right there, right? Is that the same thing as log base 10 of 2/3? And we see that it is. Okay? So if we abide by those rules, merge things together through addition or subtraction, we can rewrite these things. Okay? Now, tomorrow,